Hi all, my name is Karan and it has been 2 months we are learning engineering mechanics subject. So today we will see resolution of forces chapter type 2 numerical. So this type 2 numerical is non-perpendicular oblique components. So whenever we will calculate oblique components then formula will change. So first of all see understand this question. Determine components of the 1000 Newton force along the lines A dash and B dash axis shown in the figure. So here see, this is A dash axis and this is B dash axis. So along those two lines we will resolve this 1000 Newton force. So first what we will do, we will take this force and we will nomenclature it as F1 and it is along A dash, and this another component, it is along B dash and we will consider this as F2. So we saw in our previous lectures that whenever we calculate non-perpendicular oblique components then we need both angles. Consider this as F between F and F1. So we have 30 degree between F and F1, but we don't have angle between F and F2. We don't have this angle. So we will calculate this angle first. So let us consider this angle as theta. See here, observe this B dash line is horizontal line. So that means it is 180 degree. So how to calculate this theta? Theta is equal to 180 degree minus the 60 degree plus 30 degree. So 60 plus 30, it is 90. So 180 minus 90 is 90 degree. So this theta is 90 degree. Now we will calculate component F1. This component, vertical component F1. So F1 component formula is F1 is equal to F into C. Just consider this angle as alpha and this angle as theta, as we already considered. So here how formula will develop. See, we are calculating this F1 component, F1 oblique component. So attached to that F1 oblique component angle is alpha with that force. Fn between F and F1 angle is alpha, but don't take this alpha in numerator, just take this another angle, theta angle, theta, yes, sine of theta upon sine of alpha plus theta. So that way this formula will develop. So F1 is equal to F, we know that F is 1000 Newton and theta, we also know that theta is, we already calculated it, 90 degree upon sine of alpha plus theta. Alpha is already given, it is angle between F and F1 and it is 30 degree. So 30 degree plus 90 degree. So F1 is equal to 1000 into, so sine of 90, it is 1 upon sine of 30 plus 90, it is 0.8660. So this f1 is 1000 into 1 upon 0.8660. It is 1154.73. And unit is, see, our force is in Newton, so unit will be in Newton. So we calculated F1 oblique component and its value is 1154.73 Newton. And this F1 component is along this AA dash. Now calculate F2 component. This is along BB dash. So just see how formula will develop. So that F2 component is equal to that force F upon sine of, don't take angle in numerator, do not take angle between F and F2, take another angle alpha, so that alpha will come in numerator, upon sine of alpha plus theta. So F is 1000 Newton upon sine of alpha is 30 degree upon sine of alpha plus theta. Alpha is 30 degree and theta we calculated it 90 degree. So 1000 into, so here see, sine 30 plus 90 degree 0.8660, and sine 30 degree, sine 30 is 0.5. So 1000 into 0.5 upon 0.8660, it is 577.367. And unit is again Newton. So we calculated F1 and F2 oblique components. So in this numerical, we need both angles between F and F1 and between F and F2. So F is actual force and F1 and F2 are oblique components of that F force, but here it is oblique component, that's why we need both angles between F and F1 also and between F and F2 also. That's why we calculated theta first, and then thereafter with the help of formulas, F1 is equal to F into sine of theta upon sine of alpha plus theta. So this theta, now we are calculating F1 component, and see, we are calculating F1 component, but in numerator we are taking angle as between F and F2, opposite angles, and in denominator both angles, sum of both angles, and here always sine. So just remember this formula, how formula is developing, understand that only, and just put your values in formulas and you will get that components. So that way our numerical completes. Thank you very much.